Hello class, today we're going to talk about two things. First, interpreting a diagram, and second, angled relationships. Both of these are really pretty simple, so shouldn't take us too long. First thing, interpreting a diagram. If you have a diagram like this, and there's going to be lots of diagrams in geometry, there are some things that you can assume to be true and some things that you cannot. So first off, on this diagram, one thing that we can assume to be true is all the points are coplanar. If it looks like it's coplanar, it is coplanar. That came out really ugly, but that's all right. Okay, other thing that we can conclude is that point A, B, and C are collinear and that B is between A and C. If it looks like it's on a line, it is on the line. If it looks like it's there in between the 2 points, that's where they are. We can assume that things are in the relative position to where they appear to be. So we can assume that. Can we assume that D, E, and C are collinear? No, there's not a line connecting them, so we cannot assume that. But we do have a line here. And that's another thing that you can assume. Lines that appear to be straight are straight. Okay? Next thing we can assume that line AC, ray BD, and ray BE intersect at point B. Since it looks like they come together right there at point B, we can assume that they really do. Okay, that's one of the things that we are allowed to say. Well, it looks like it, so we're going to go with it. All right. Next thing we're going to talk about, we can say that angle DBE and angle EBC are adjacent angles. And we can also assume that angle ABC is straight. We can assume that if it looks like a straight line, it is a straight line. So angle ABC is a straight angle. We can assume that. And we can assume adjacent just means that they're next to each other. So angle DBE is right there next to angle EBC. We can assume that to be true. And the last thing on here that we can assume to be true is that point E is in the interior of angle DBC. Again, we can assume that things are in the relative position to where they appear to be. Not necessarily in the exact position, but the relative position. We know it's somewhere inside angle DBC. We're not going to assume that, well, it's drawn there, but it could be anywhere. Now, these are very important. This is what we can assume to be true. We can't assume everything because we don't know who drew the picture. And maybe whoever drew this picture is just as bad at art as I am. And so just because it looks like it doesn't mean it is. And the other thing is I can't draw a straight line. And so what can we assume, right? I can't draw it, but we can assume that it's straight anyways, even though it looks terrible. All right? So what can we not assume? What cannot be concluded from this picture? All right? Well, one thing we can't conclude, we cannot conclude that segment AB is congruent to segment BC. It looks like they're the same length, right? But are they really? I don't know. I didn't measure them, and maybe they're supposed to be and they don't look it. Maybe they're not supposed to be and they do look it. We don't know how good an artist this person was. So we cannot conclude that segment AB is congruent to segment BC. That is something that cannot be concluded. We don't know. What else do we not know? Well, we don't know that these two angles are congruent. They kind of look congruent, but I don't know. This one could be 59 degrees and that one could be 58 degrees. I don't know. That's not something that I would be able to tell with the naked eye. So we cannot conclude that angle DBE is congruent to angle, EBC. We cannot conclude that these two angles are congruent because they could be off by just a little bit, And that's not something that we'd be able to tell just by looking at it. It would have to be something you measured or something along those lines. All right, and the last thing on here that looks like it might be true, but we really don't know, we cannot conclude that angle ABD is a right angle. It looks like a right angle, looks pretty close, but it might be an 89-degree angle or a 90.5 degree angle. That little bit of a difference is not something that you'd be able to detect with the naked eye. You'd have to actually measure it to find out. So we cannot conclude that angle ABD is a right angle. Now, there are ways that we could find out. There are ways that I could change my picture here so that I could conclude each of these things. And we've talked about all of these in the past. They have to have markings, right? So for example, if I want to show that segment AB is congruent to segment BC, I could put little tick marks on it, like that. That shows that AB is congruent to BC. If I want to show that angle DBE is congruent to angle EBC, and I drew this and I didn't draw it very well, but these are supposed to be congruent, I want to show that, I can put those little arcs on it, like that. And now I can say, oh, well, hey, it's marked, so even though it doesn't look quite right, it is. All right. And the last one, angle ABD is a right angle. I could show that by putting that little right angle square in the middle of the angle right there. And that would show that these things are true information. Right? But if they don't have these markings, then I really don't know. You'd have to measure it or do something else like that. All right. And so that is what I wanted to show you there as far as what we can assume on a diagram. Okay, but now I want to look at angle relationships. Okay, so angle relationships. So angle relationships, lots of different stuff we can do here with angle relationships. So the first one we're going to look at is vertical angles. Okay, vertical angles, this is when you have two angles across from each other on intersecting lines. They're always congruent. Okay, so for example, I have two intersecting lines like that, and as you see, this made a bunch of angles, right? Well, the vertical angles are these two across from each other, and they will always be congruent every single time. Now, I know you're saying, well, hey, what about those other two angles? Yes, those are vertical angles too, and these are congruent to each other as well. Right? Vertical angles. Has nothing to do with going up and down, right? Like vertical usually. What it means is that they all have the same vertex, is kind of where that comes from. All right, vertical angles, not a big deal. Easy stuff. Next, we have, we'll just go around this way, a linear pair. A linear pair are two angles that are adjacent and well, actually, we'll come back to that because we haven't talked about adjacent or supplementary. So we'll go to the adjacent. Two adjacent angles are next to each other and they share a common side. So, for example, I could have these two angles here. Right? Angle 1 and angle 2 are adjacent to each other because they're right there next to each other, right? They're touching, and they have a common side. Another thing that has to be true about adjacent angles is they also have to have a common vertex. Because if you remember, a side of an angle is a ray. And so if I had this right here, it was ray AB, and I flipped around and said, no, this one's got a vertex up there, B, and it's BA. Remember, those are two different rays. Okay, so they have to look like this. Okay. Next, complementary angles. Right, complementary angles, these are angles that are just really nice, and they always tell you that you're pretty and everything else. No, that's not what these are. Complementary angles, these are two angles whose sum is 90 degrees. Okay, so for example, if I have an angle right here, and this one measures, let's say, 30 degrees, and then I have an angle over here, and this one has a measure of 60 degrees. Complementary angles do not have to be next to each other, but we can see 30 plus 60 equals 90, and so these are complementary angles. They can be anywhere we want. It doesn't matter as long as they add up to 90 degrees. Supplementary angles is very, very similar. These are any two angles whose sum is 180 degrees. So, for example, if I have an angle here who has a measure of 110 degrees, and then I've got another angle here that has a measure of 70 degrees. 110 plus 70 is 180 supplementary angles. And so now we come to linear pair. Linear pair is two angles. Let's see, what color have I not used? Black, I guess. Two angles that are adjacent to each other, like that, and also supplementary, like this. And so the only way that can happen is like so. All right? So angle 3 and angle 4 are supplementary, and we know they're supplementary because this is a straight line. And remember, that was one of those things we can assume. If it looks like it's supposed to be straight, it is. And so since that's a straight line, that makes it a straight angle, so it adds up to 180 all the way across. And so these two together is supplementary. It adds up to 180. They share a vertex and a side, so they are also adjacent. Linear pair. All right. So now what we're going to do is a little bit of examples. All right. So what we're going to do, I've got a diagram that we can't see very well, so I'll zoom out. There we go, now we can see. All right, we need to name an angle adjacent to angle CDF. All right, so let's see, where's CDF? Let's see, there's C, D, and F, so we need an angle adjacent to angle CDF. So it has to have the same vertex, D, and it has to have one of the same sides, ray DC. So that would be, we could say CDF, so CDB, right? Angle CDB. Now there is actually another one. There is another one here, so I'm going to go ahead and, it doesn't ask for two, but I'm going to go ahead and give you the other one too. You could also do angle CDA, this whole big angle right there. All right? Both of those are adjacent to angle CDF because they're right next to it and they share a vertex and they share one of the sides. All right, we need to name two pairs of vertical angles. Remember, these are pairs. Vertical angles will always come in pairs. So let's see here. Let's see, angle AB, no, it doesn't work. Because see, as you remember, it has to go all the way across. So we couldn't do angle ADB and angle CDF because those don't go across, they're not straight across the intersection there. So that's what we got to find. And that we would find, let's see, here's a line, line EG, which goes all the way across line DI, right? And so this is where we can find some vertical angles. We have angle DFE right here, and directly across that vertex where these two lines intersect and go all the way across, we have angle GFI. Now I did ask for two pairs, so that means I need another pair. And as we saw here, there's always going to be two pairs, right? So the other one is going to be this obtuse angle here, DFG, and across from that is going to be angle EFI, which is a little hard to see because we've got ray FH there in the middle, right? But still, we have this whole big angle there, which is congruent to that whole big angle there. So now we need, what do we need? Two linear pairs. So what was a linear pair again? Linear pair is where these two angles are adjacent to each other and they make a straight line. Okay, the two sides that are not adjacent to each other will be opposite rays. So where can we do that? And there's actually quite a few different things we could do here. Let's see, we could go with angle ADC right here, and then angle CDF going that way, right? Okay, and just so you can see it, I'll go ahead and there's ADC and CDF like that. All right, now we need another one. Actually, how about you pause the video and you find another one? There's a couple of them here. All right, let's see here. What did you find? There are a lot of them. So we will just go with, how about down here? We have line EG, right? Got a ray coming off of here. So I could say angle EFH H, and let's see, that uses ray FH, so I could say angle HFG. Now that's not the only ones on here. We could also have said over here, we could have used GFI and IFE. That would have worked. IFG and then GFD would have worked over here. Use these two angles. Right? Could have come back over here. We could have used ADB and DBF. Right? Used these two angles there. That would have worked. Lots of different things we could have done. We could have, here's some. We could have done AFE and EFI would have worked. Would AFE and EFH work? No, because there you see the two that aren't being shared don't make a straight line, do they? It turns there. So that's not good. So remember, linear pairs form a line. It's a pair of angles, two angles that form a straight line. So it's linear. All right, now we get into stuff a little bit more complicated. Let's see here. Angle BDC, so BDC right there, and angle HFI, HFI down there, are complementary. We need to find the measure of angle HFI. So tells us they're complementary. What did that mean? Let's see. Complementary means they add up to 90 degrees. So I don't know what these are, but I do know that whatever they are, they add up to 90 degrees. So that's what I'm going to do. I'm going to say 9x plus 2 plus HFI, which is 7x plus 8, equals 90 degrees. Now I can solve for x. First we combine like terms, so I've got 10, and that would be 16x plus 10 equals 90. So we subtract 10 from both sides, and 16x equals 80. Divide both sides by 16, and x equals, let's see, that's 5. Yep, 5. So x is 5. I'm not asked for x. I'm asked for HFI. So HFI. So 7x, but I don't want x. I want 5. 7 times 5 plus 8 equals the measure of angle HFI, whatever that is. So 7 times 5 is 35. 35 plus 8 would be 43. So the measure of angle HFI equals 43 degrees. Right, just like so. And I need to put a box around it so I can find it later. Alright, what's it ask for next? Last one here. And we want the measure of, let's see, angle EFI, so this whole big thing, and angle CDF are supplementary. We need to find the measure of angle CDF. Okay, so this one's going to be a little bit tricky. Now, if I had some expression here for CDF, then I could say, well, this one plus all of that is 180, but I don't have that. But I do know that they are going to be supplementary, right? Adds up to 180, supplementary. So this plus all of that equals 180. So this is what I'm going to do here. So the measure of angle CDF plus, let's see, EFI. So EFI is all of this. And so I can add that together with the angle addition postulate. So this is 20x minus 6 plus 7x plus 8 equals 180. Well, that's lovely, but what's x? We already found x, didn't we? X is 5. We found that right here. So I can just plug that in. So measure of angle CDF plus 20 times 5 minus 6 plus 7 times 5 plus 8 equals 180. All right, so now I need to combine my terms. Where's my calculator? There it is. We'll just do it like this, saves time. So we've got, where'd it go? 20 times 5 minus 6 plus 7 times 5 plus 8, which is 137. So I have the measure of angle CDF plus 137 equals 180. Subtract 137 from both sides. The measure of angle CDF equals, what is that? 43 degrees. Because it's an angle. Angles are always measured in degrees. And there it is. So, hopefully that helps. Remember, vertical angles are always across from each other with straight lines. Straight lines have to go all the way across. Not like that. We don't have any vertical angles there. Adjacent angles have the same vertex, and they have one adjacent ray. It's the exact same ray, one common side there. Complementary angles add up to 90 degrees, but they do not have to be next to each other. Supplementary angles add up to 180 degrees, don't have to be next to each other. Linear pair is supplementary and also adjacent, so these do have to be right there next to each other. All right. Things you can assume, we can assume that all the points that look like they're on the same plane are on the same plane. If they look like they're on the same line and that line is drawn, we can assume they're on the line. We can assume that straight lines are straight. We can assume that things look to be kind of sort of where they are. So B is between A and C. E is inside the angle there. And that's about it. We cannot assume congruence of anything. We cannot assume any measures of any angles or the measures of any sides. All right? Those have got to be marked. All right? And that's it. Hopefully you found that useful, and I'll see you next time.